Hey guys, this is the next video. This one is on constructing networks. So as we've talked about previously, networks are useful for modeling the physical connections or relationships between items of interest. So obviously you're going to be asked to create some networks of things in a particular questions. So some of the thinking behind how you would do this constructing networks is, firstly, you need to identify what the items of interest are, and they're represented by nodes. Something to think about is the position of the nodes in your network is not really important. So sometimes you're going to have questions that don't actually have a physical representation, like relationships between people. The positioning of that isn't important, but I can give you some tips on how to think about that and to help you draw these networks, because it can be really annoying having to erase nodes over and over again. So firstly is to understand that they're not important straight away. However, if the network represents something that physically exists, usually the question will have a diagram or something, then your positions are better to be similar to the positions in the actual question or in the drawing that you're given. They don't have to be in the same position. But what I'm saying is, if they do physically exist, the connections are going to be in such a way that if you place them in the right places according to the question in the first place, then the connection is going to be easier to draw. That's not going to be the same as if the thing that you're trying to represent doesn't physically exist, because the connections can be between anything. Okay, so we're going to do a couple of examples here to explain what I mean by that. If you're given a map or a drawing of the thing because it physically exists, then place nodes in similar positions to that. If not, don't worry too much about it. Also, the other thing is to draw edges or arcs between nodes according to the information provided. So if they're arcs, you're told a direction they can go, and only connect nodes that have a physical relationship or a connection between them according to the question. So let's do an example. This is an example with no physical representation. Why is that? Because it's a network representing friendships in a choir. So if someone was standing like 20 kilometers away from another person, that doesn't break the connection between them. They're still friends. These two people might be standing right next to each other, but they're not friends. So the network, the line that we draw between the nodes, it doesn't matter. Okay, so here there's no physical representation, so the positioning is not important. What is important is the lines that we draw between them. So something to think about here is that, yes, I'm saying that the positions don't matter, but you could spend hours and hours, ages, drawing these people if you were just to drawing these networks if you were just not to think about it. To start off with, let's say you put nodes just in a line. What's going to happen if you do the nodes in a line like that? You're going to look at the relationships and connect them like this, and it's going to get messy, and that's fine, and you wouldn't be marked down for answering that question, but it might just be a little messy for you. One thing to think about is that the people that have the most connections, they're going to have to connect to a lot of other people. So they're better off being in the middle. Okay? So there is no right or wrong answer here. It's just making it easier for yourself. So what I'm going to do is I'm going to chuck Lisa, Rob, and Lucy in the middle, because they have the most connections. And I think that that's going to help me draw this a bit easier. Rob and Lucy in the middle. So let's see if they've got any connections with each other. So I've positioned these guys. Lisa is friends with Pam. Lisa's friends with Rob, so I'm going to draw a connection between them. And she's friends with Jackson. I haven't drawn Jackson yet, so I'm going to leave that for now. Rob is friends with Lisa. I've already drawn a line between them. Rob's friends with Lucy, So we need to draw a line between them. And he's friends with Sylvie. I haven't drawn Sylvie, so I'm going to leave that. Lucy is friends with Rob. I've already drawn that. Friends with Jackson and Kate. They're not drawn. Alright. Now let's look at the next most related people. Jackson's friends with 2. So Jackson is the next candidate I could chuck in there. He's friends with Lisa and Lucy, so it might be helpful for me to put him in the middle there. Jackson. Here. And Jackson's friends with Lisa and Lucy. Position him. Drawn that. Lisa is friends with Jackson. I already drew that line. Lucy is friends with Jackson. I already drew that line. So we just need to draw the remaining friends in that are only friends with one person. So if Pam is only friends with Lisa, so she's a bit of a loner here. Pam is connected to Lisa. Lisa is friends with Pam. I already drew that line. Jackson's dealt with. He's friends with Lisa and Lucy. He's connected. Rob is friends with Lisa, Lucy, and Sylvie. And Sylvie is only friends with Rob, so I could draw her external here. Sylvie. So I've positioned Sylvie, I've indicated that she's friends with Rob, and I've also indicated that Rob is friends with Sylvie. Lucy is friends with Rob, Jackson, Dunn, and Kate. Kate is only friends with Lucy. So if I put Kate here, she is connected to Lucy and no one else. So what I've done is drawn a representation of the friendship groups here. And that is correct. What you'll find on on one of the pages of your book is that they've drawn a very similar thing in a completely different shape, because there's no particular right answer. You just need to use the question to determine the connections. What's important is the connections, not the position of these dots. All I'm saying is that the people with more connections with others, they're better off being in the middle somewhere. Don't put them on the edges, because then you'll have to draw edges like going all around. Okay? So that's an example with no physical representation. Here is an example with a physical representation. So what I was saying above is, if there is a physical representation, the fact that it exists means that the connections have to exist as well in real life, so the positioning will be helpful here to follow the diagram. Okay, so even before I've started, I've had a look. You've been given a drawing. You're better off placing the nodes in similar positions as they are in the diagram physically. So that's going to be the lounge, dining, kitchen. See how there's going to be a sort of a link between top left here for the lounge, top left node there, dining in the middle, kitchen on the edge there. Hall is sort of central. There's a bedroom, a bath, another bedroom, and a veranda. So we have represented as nodes all of the things of interest. That's the lounge, dining, kitchen, hall, bed 1, bath, bed 2, veranda. So what I'm saying here, and what I've repeatedly said over and over again, if the thing exists physically, if you've got a drawing, try to place the nodes in similar places to where they are on the drawing. This will help you out a lot. So the lounge has a door to the hall, so there's access between them. The lounge has a door to the dining, so there's access between them. There's a door from dining to the hall, so there's access between them. Bedroom 1 has a door to the hall. so there's access between them. There's no door from bedroom 1 to the lounge, so we don't connect those. There's no door from bedroom 1 to the bath, so we don't connect those. There's a door from bath to hall, so connect those. There's a door from bath to bedroom 2, so they're connected. There's also a door from bedroom 2 to the hall, so they're connected as well. There's no door from bedroom 2 to the veranda, so they're not connected. There's a door from the hall to the veranda, so they're connected. There's a door from the veranda to the kitchen. And there's a door from the dining room to the kitchen. So dining is connected to the kitchen, and veranda is also connected to the kitchen. So what you'll see is a kind of similar diagram in your textbook, but that's just an example of how you would draw a network representing something that actually physically exists. You're shown in a diagram in your question. It's not just relationships that don't physically exist. Hopefully that helps you out with this series of questions, and I'll see you in the next video.